Alrighty, for this one, exercise number 8, light and color. Turns out that 8.1 is the exact setup of the experiment we just did for 6. I guess they wanted us to just continue the conversation. They are asking us to go ahead and set this up exactly as we had before, and then rotate the lens again until we actually see the light spread out. So again, I'll go ahead and do that. I can move this, take this guy back off. This is something we just got done doing. We can look at this refracted ray, and at some point it starts to spread out into the red and the green and the blue, which is what they want us to observe. That's fantastic. So I'm going to put this back to where it was, and here is our ray again. I'm going to put this down here for now. And I'm going to go ahead and turn this back on. Again, that's all it asks us to do. It says, oh, by the way, set up the equipment as shown in 8.1, which we just did, so that this so that a single ray, notice the color separation at large angles of refraction. Yep, we just did that. That was called experiment 6. Okay, so now they'd like, yes. Set up the, to further investigate, set up the equipment as shown in figure 8.2. Okay, so that's this picture down here. What they'd like us to do is they would like us to, first of all, take the cylindrical lens off. So I'm going to go ahead and do that. Put that guy down here. And then take the slit mask on this side and make it go away. I'm going to try to do it with one hand. This is usually a two-handed thing, but I'm holding my phone. There's the slit mask. So now, turn off the light. We have 7 rays of sunshine coming through. That's fantastic. And now what we're going to do is we're going to make each of these rays of light a different color. And we're going to do that using a filter. Okay, so here's a filter. And you can see right away, it says labeled red filter. I don't know if you knew that or not. This is the red filter. When you look through this red filter, everything becomes red. Okay, everything's red now. A red optical filter or a red light filter is the opposite of how we use the word in chemistry, like a coffee filter. Okay, so a coffee filter that you put in your coffee pot is actually I guess you could call it a coffee filter. It lets the coffee through, but usually when we talk about a filter, we talk about what is filtered out. So a coffee filter is really a coffee grounds filter. We put the grounds in the filter basket. This is an automatic drip coffee. We run hot water through it. It extracts the flavored oils and the flavored caffeine and other things from the coffee, and the grounds get stuck behind. So a coffee filter does not let the grounds through. An absorption filter like this is an absorption. We'll be talking about absorption later on. Absorption is not discussed in these activities, but we'll get there. This is an absorption filter. What it means is the molecules inside this plastic, it's probably acrylic, but it has red colored molecules, and those red colored molecules are called red molecules because they happen to absorb or block all the other colors of light in the visible except for red. Red is the only thing that gets through. So the reason why I bring up that it's an opposite of a coffee filter is, imagine having a coffee filter that only let the grounds go through and blocked the water. That's what this guy is. So with this red filter over my camera, I can only see red. So what I'm going to do is I'm going to take this and turn off the light and go dark. And whether we have bright light or not, again, everything is red. I'm going to take this red filter and I'm going to try with one hand, and then if I can't do it, I'll come back. But I want to block half, or again, the middle is still white, and I've blocked these 3, 1, 2, 3, 4 over there. Blocked those guys. What I want to do are these 3. So now what we have is we have the light hitting, some of the rays hitting the red filter, and some of the rays not. This other filter I'm going to grab is called the blue-green filter. Why is it called the blue-green filter? Because it's both blue and green. It sees just blue, but it has a green strip on the side of it, which is right there. And the reason why it's blue and green is because it allows blue and green to get through there. Now, one of the things I just noticed is that the magnets are on the wrong side for me to do this. I need to take the red filter and move it over. See if I can do this without messing it up. There we go. put this red filter. I also need to do this so I don't block it. There we go. Going to slide the red back on again. Here we go. I think I can get 2 of those guys. There's 3. And then I'm going to take the red green, which is this guy, and put it on the other side and bring these guys back over. Here we go. And slide it a little bit more. I should be able to get 2 greens. There we go. So I happen to have 3 reds because there's 7 of them. I have to have an odd one out, but I have two blues, 2 greens, and 2 reds. Fantastic. I've accomplished that by putting it through 3 separate filters. A red filter, which is there, and then a green slice filter, which is attached to glued to a blue filter, the blue-green filter. So all I'm doing is, and I have a German Shepherd in my house. I'm getting rid of the German Shepherd fur. Thank you. We have these lovely colors on the other side. What I can do with the cylindrical lens is I can take the cylindrical lens and place it on this side. And what that does is I can make, because of the index of refraction, I can make these colors of light come back together again. Okay, you can see there. Wonderful. And what I want to do is, you know what, I'm going to do it this way. Just going to put it there. And then what I'm going to do is I'm going to go over here to my projection screen here. My screen. Put it down in the dark back here. I'm going to switch my camera in my hands. And I'm going to take a look at this viewing screen here and see if we can do this. I'm going to take these guys. There's the 3. And there's the... But if I get... Here's the 3. Here we go. There they are. Viewing screen. There's the reds. The reds are on the other side because the cylindrical lens has set it to the other side. There's the green and the blue. But if I bring these guys together so that the red and the green all come together, what we get is we get white light back again. Now the white light that we get back again, somewhere in there seems to be some white light. It all depends on how these things go together. But the white that we're seeing is because our eyes have red, green, and blue sensors. It's how our transducer was set up inside of our eyes on our retina. Because red corresponds to a certain third of the light, and green is the middle third, and red is the final third. All together, it looks like the same white light that we see over here. So what it does is it sort of optical illusion tricks our light into seeing red again. And for anybody who happens to have done theater, maybe at LaSalle back when we were doing theater, or maybe in high school back when we were doing theater, and if you've been on stage, you know that stage lights are not white lights because white light happens to drown out. Stage lights are red, green, and blue because what it does is it makes things look white that need to look white, but it makes their colors pop, which is kind of cool. So what we do here is we have all of these white lights on the other side. Pretty nice. We can put these red and greens and blues together to make white. And of course, this is also how screens work on devices. This is how the screen on my computer works. It's how the screen on my phone is working right now. It does not have white light sources coming from a screen. It only contains red elements, things that glow red, things that glow green, and things that glow blue. I said glow blue. And when we turn them all at the same time, my phone to my eyes looks like it is white. I can't see them individually. Yes, if you take your phone and you put it way up to your eyes, or maybe a microscope, you'll see the individual reds and greens and blues. Technology-wise, when we used to have televisions that were made out of cathode ray tubes, you could literally see, because the resolution was not very good, you could see the red and the blue and the green pixels inside the device. And then that's why they were called RGB monitors, for red, green, and blue. They were called monitors rather than flat screens. That's pretty cool. Nice. So that was that particular portion of this guy. We have one more thing, and that is to take a look at, that was putting them back together again. This next thing is to observe what happens when we put light through a particular color of filter. Again, I'm going to take these guys back off again. And the first thing we are supposed to take a look at is, I need to look at the instructions, is set up the equipment, observe the light rays that are transmitted and reflected from the green filter. So here's the blue-green filter. Here's the red filter. Oh, crap. I have to go get the green filter. I forgot to grab it. I only have these two. Hold on a second. Let me put you down. Okay, I'm running over here to my supplies. It's in the dark. As before, if I happen to kill myself, don't somebody get me. Where's the green filter? Green filter, green filter. Found it. Found it in my little light kit. Way over here on the other side of my basement office. I found it. I'm cleaning it right now on the shirt tail of my shirt. And we're back. Hello. We're back. Green filter. And I still have a little bit of, it's been a while. Put this guy back down again. Again, these kits are used by everybody in the lab, so I'm wiping off the fingerprints of the students who used it last. I try not to put my fingerprints on things. I end up doing it, but hey, we back? We better? Hey, nice. It's nice and clean. It's a green filter. Look at that. So what we can do is we can turn this guy off. And they're asking us to take the green filter, not blocked by magnets, and put it down here on here. And they're asking us, hey, what is the color of the light that makes it through the green filter? And I think it's pretty obvious. I'm going to try to not have it blocked by the magnets, of course. You can see where the magnets are blocking it. But from this side, they all look green because they're on this side. But if I take my camera to this side, they're white on this side and they're green on this side. So what gets through happens to be green. However, if I look at the first front surface, remember, it has to go through in order to turn green. If I look in the front, it acts like a mirror, and there's white light being reflected in the front. So we get another part of the reflection law. Angle out equals angle in. That was the first one. Plane in equals plane out. It was sort of crawling up the disk, and now it's crawling back down the disk. Distance in front equals distance behind. You can see I have a reflection inside there. In fact, I'm actually seeing a virtual image of the slit guy on this side over here. And then also now we have for reflection, color in equals color out. So there's white light striking the front of this reflective piece of plastic, and the reflected lights, lines happen to be white. Same color in, same color out. On the other side, yes, there's some refraction going on, but really what we're looking at is transmission. This thing is not designed as a lens, so it looks as if they're continuing straight. There's a little bit of refraction going on, but not enough for us to measure. But what's special, because it is an absorptive filter, is that it is removing all the other colors except for green, which is kind of cool. So now what they're asking us to do is they're going to ask me to place the red filter as soon as I find it. That's the blue-green. Let me find the red filter. It is here. Here's the red filter. They're going to ask me to place the red filter behind the green filter, and that's going to require me to use two hands, I think. Let me give this a shot. So here's the green filter. It is there. You guys are not going to like this. I'm going to put down my phone and do it, and then hold it with one hand, and then pick my phone back up. So again, I got to turn this over to not get the magnets out of the way. There's that guy. There's the green filter. And I'm going to go ahead and let me put you guys down for a second. Thank you. I'm going to take the green filter. Hello, green filter, this is me. I'm going to take the red filter and put it behind it and hold them with my hand here as soon as I get this done going here. And then I'll bring my hand back. Okay, now I'm back. So what do I have? I have the green filter in front. How do I know it's green? Because the lights coming out of the green filter are green. Okay, and if I look behind the red filter, there's no light at all. The light is gone. It's as if it is a black filter. The reason why it's gone away is, remember, the green filter already removed all of the red. The red has been blocked. We'll be talking about absorption later. The energy of red is actually being not being reflected, but being absorbed and turned into thermal energy. This filter is slowly starting to get warm. There's the green, and on the back side of the red, since the red has already been taken out, there's no red that's going through. But if I look really, really closely, and especially if I do this properly, let me go ahead and put this guy down and put this guy there. So now there's all the green. Now I'm just going to use my hand, my other hand. It's magnetic. You'll notice that this red filter, again, it's red, right? It's red. The red filter is not letting the red through. It's being blocked. But look at the reflection, okay? If you look at it really, really closely, it's hard to see what color it is, but it's reflecting green. The red filter is reflecting green, and in fact, it's turning into a green mirror. I can see the green inside the mirror because the law of reflection says that, in fact, I put my hand behind there, the law of reflection says color in equals color out. It doesn't matter what goes through. So this red filter on its reflection side is reflecting green light before it ever gets a chance to go through the filter. Once the green light goes through the filter, because there's no red left, it too gets absorbed, and there's no absorption on the other side. So if I go ahead and take this red filter and put it and stack it there, and then take my light and go ahead and come down here and see through it. You can see a little bit because these things are not perfectly awesome filters. That was a very bright light, and it's not completely out there. You can see some rays on the table here, but if I come up here, you'll notice that the rays don't appear to be there because it has been filtered out. They're not perfectly. It's not 100% filtering out all of the green, and this is 100% not. No, sorry, 100% filtering out all the red, and this is not filtering out all of the green. There's a little bit in there. If we go ahead and do this, you can see them through here. But so it's not perfect, but you can still see it, which is pretty impressive. So we can play with all kinds of filters, and we can play with all kinds of reds and greens and blue light-emitting diodes and different types of liquid crystals in our displays to make all the colors that we need to have all of our devices have whatever color that we desire. Pretty cool stuff.